Hi, everyone. So here are the last two examples from the notes today with the volume of cross sections. So example 3 has to do with cross sections that are going to be perpendicular to the y-axis. So we are told that the region R in the first quadrant enclosed by the graphs of y is equal to 2x and y is equal to x squared is the base of the solid. So we know that we're not going to be revolving anything here. For this solid, the cross section is perpendicular to the y-axis now, and we're talking that they're squares. We're looking for the volume of the solid. So I'm just going to do a quick sketch of what the enclosed area looks like. So make a quick sketch of my y is equal to x squared. And then I'll do my best for this y is equal to 2x. So now we're talking that the cross sections are now going to be going the other way. So we know that they're going to be perpendicular to the y-axis. So the bases are now going this way. So if we think about what that means in terms of our integration, we're going to be integrating with respect to y. And when we integrate with respect to y, remember that we're looking for right minus left when we're going to be finding the length of the base. So my base is going to be my right minus left. But remember that if we're integrating with respect to y, we need to have these in terms of x equals equations. So if I do this y is equal to 2x and solve for x is going to be equal to 1/2 y. And then over here, when I solve for x, my x is technically going to be equal to plus or minus the square root of y. But since we are only working in the first quadrant, we're actually only worried about the positive root of y here. So if I look at my right function is actually this x squared, which means that that's going to be my square root of y. And then if I look at my left is this y is equal to 2x, which means that that's going to be equal to my 1/2 y. So that's the base of my square. So we're talking squares here. So the base length of my square is going to be the square root of y minus 1/2 y. And remember that since we're talking a square, all the sides are going to be the same. So when I do my area of my square, we're going to be doing the side squared. And my side squared is just going to be the square root of y minus 1/2 y quantity squared. So when I set up my integral here, now we're going to be talking the integral from c to d of a of y dy. So my a of y function is this quantity squared. And now I want to look for the y values that we're going to be integrating with respect to. So the graphs intersect definitely at the point 0, 0. So I know that my starting y value is going to be 0 or my lower bound is going to be 0. And then I want to know where these two graphs are going to intersect up here or the y value of that point. And I believe that that point is actually going to be 0. I'm sorry, it's going to be something 2. And again, you can find that using your calculator, or you can find that algebraically by saying, okay, I want to know where 1/2 y and the square root of y intersect. And if you solve that algebraically, you should end up getting y is equal to 2. And then we can just use our calculator to do this for us. I think when you integrate that, you end up getting something like 0.4039. So that's the volume of our solid with our cross sections that are perpendicular to the y-axis and their squares. All right, and then the last example is having to do with isosceles right triangles. So now we're talking the base of a solid. Again, we're not revolving anything here. Is the region enclosed by y is equal to negative x squared plus 1 and y is equal to 0. So I'm going to quickly sketch that out. So it's going to look something like that. And y is equal to 0. It's going to bound it. So we're talking about that region in here. So we're looking for cross sections perpendicular to the x-axis. So my bases are now going to be going back this way. And the bases are isosceles right triangles. My base is going to be a cross section of an isosceles right triangle. So now that we're talking perpendicular to x, we're going back to integration with respect to x. So when I find the length of my base, I'm going to be doing my top minus bottom. And in this case, my top function is going to be that negative x squared plus 1. My bottom function is actually going to be 0. So my base is going to be negative x squared plus 1. So if I think about what that means in terms of a diagram, we're talking about an isosceles right triangle. So I know that in an isosceles right triangle, my legs are going to be the same. And it's telling us that this is the base is our leg. So my base and my height are always going to be the same length in an isosceles right triangle. So if my base is this negative x squared plus 1, my height is also going to be the same thing. So when I go to find my area, now that I know my height and my base, my area is going to be relatively easy to find. So my area of my triangle is going to be 1/2 base times height. So 1/2 times the base of negative x squared plus 1 times the height of negative x squared plus 1. I can actually just kind of clean this up a little bit and write that as 1/2 times the quantity of negative x squared plus 1 squared. So now I can go ahead and go to my volume. So since we're talking integration with respect to x, we're going to be talking about the integral from a to b of a of x dx. And our a of x is just this expression. And since that 1/2 is a constant, I can pull that on the outside of the integral. So on the inside, I'm just left with negative x squared plus 1 squared dx. And then if we're talking x values here, we're integrating from the x value of -1 to +1 because that's where my graph is going to be crossing the x-axis. And I believe this does actually give you a value that you can write in fractional form. So I think you end up getting 16 over 15 when you do this integral, but when you divide it by 2, I believe you end up getting 8 over 15. So that is the volume of our cross-section perpendicular to the x-axis. That is an isosceles right triangle. So let me know if you guys have any questions, and you can go ahead and try the homework.